Now, let's go for another topic, physical quantities, which we learned a little bit, but we go more in detail. What is a physical quantity? Any quantity which can be measured directly or indirectly, we call it as a physical quantity. There are two types of physical quantities. What are they? Number one, fundamental quantity, and number two, derived quantity. Let's see what is a fundamental quantity. Any quantity which doesn't depend on any other physical quantity for its measurement, we call it as a fundamental quantity. Any quantity that is purely independent. It doesn't depend on any other quantity. And there are 7 fundamental quantities. Let's see the 7 fundamental quantities. What are they? See, length is a fundamental quantity. And what is its unit? Meter, short form m. Second fundamental quantity is the mass. We measure it in kilogram and the unit is kg. Mass is a fundamental quantity and kg is the fundamental unit. We know time is a fundamental quantity. We measure time in second. Next one, temperature is a fundamental quantity. Now you may be knowing temperature is measured in Celsius, but that is not the proper unit in physics. It has to be Kelvin. Remember, K is the letter for that. Now electric current is another fundamental quantity. Ampere is the fundamental unit. Amount of substance, the unit is mole. This is basically coming in chemistry. What is amount of substance? Look at this. It is the mass of the substance which contains same number of molecules. Look at this. 12 gram of carbon contains chemistry Avogadro number of molecules. That is 1 mole. So how much is 1 mole? 12 gram of carbon. But look at for water. To have the same number of molecules, Avogadro number, how much gram of water is needed? 18 gram. So 1 mole of water means 18 gram. 1 mole of carbon means 12 gram. For the time being, that's enough. Remember, this is in chemistry, which is amount of substance. Now, we go for another physical quantity, luminous intensity. What does luminous intensity mean? Luminous intensity is a measure of brightness of bulbs. Look at this. You can see the first bulb is less luminous because it doesn't give you as much light or as much brightness as the second bulb. So the second bulb is more luminous. And what is the unit of luminous intensity? Candela, short form CD. Among them, you don't need to know much on. Mainly, you will learn only these 3. Certain situations, you will go for Kelvin, you will go for ampere. For sure, mole and candela, you don't need to know at all. So any question on fundamental quantity? 7 fundamental quantities, you know them. What are they? All these are fundamental quantities and all these are fundamental units. There are 2 supplementary quantities which doesn't belong to the fundamental and doesn't belong to derived. I'll talk to you derived later. The 2 supplementary quantities are plane angle and the unit is radian. What is a plane angle? Look at this. This is a circular disc. Look at this. There is a line, there is another line, and the angle between the 2. Normally you measure in degree, but now onwards, remember, this is plane angle. Over a plane, there is an angle, plane angle. The unit is radian and the short form is rad. Now, we move on to another supplementary quantity. We call it as solid angle, which is the angle subtended by a solid. Look at this picture. This is a sphere and you can see the sphere and there is a surface which is golden in color. And this angle, can you call it as plane angle? No. Why not? Because it is not on a plane. It is on a solid surface. So the angle within a plane, you call it plane angle. And the angle within a solid, you call it as solid angle. And what is the unit of solid angle? Steradian, the short form SR. Now, we move on to the next type of physical quantities, which is a derived quantities. The name itself tells you it is derived from the fundamental quantities. So what is a derived quantity? It is a physical quantity which is derived from the fundamental quantities. Let's see. It's a combo of fundamental quantities. And the units of these quantities, we call them derived units. Example, area, you can see meter square. The unit, it's a combo of meter and meter. Look at density, it's a combo of kilogram, mass, m3 meter distance, combo of all. Force, remember, now we learn it as kilogram meter per second square. Look at this. To get the unit of velocity, you can see meter per second. Two ways you can write meter per second. This way, or divided by second, when it goes to the top, it becomes s minus 1. How do you get it? You have to know the equation for that. And what is the equation for velocity? Velocity is displacement divided by time. And what is the unit of displacement? You remember displacement is just distance, which is measured in meter. Time is measured in seconds. So you will have the unit meter per second. Meter divided by second. Divided by second, when it goes to the top, it becomes s minus 1. Now we go for acceleration. The unit of acceleration. For that, you need to know the equation for acceleration. What is the equation for acceleration? Velocity divided by time. And what is the unit of velocity? Just now you have learned velocity is ms minus 1 divided by another s. That becomes already ms minus 1. The s under, when it goes to the top, it becomes s minus 1 again. So it eventually becomes ms minus 2 meter per second square, just like this. But we prefer this way, ms minus 2. So remember, the unit of acceleration is ms minus 2. We move on to another quantity, which is force. Again, you need to know the equation for force. Look at the equation for force, mass times acceleration. And you know the unit of mass. Unit of mass is kilogram. And you know the unit of acceleration. Just now we derived ms minus 2. So it becomes ms minus 2. So what is the unit of force? Kilogram ms minus 2, or kilogram meter per second square. And we move on to another physical quantity, work. To know the unit of work, you need to know the equation for work, which is force times distance. Just now we have done the unit of force is, what is the unit of force? Kilogram ms minus 2 times displacement is in meter. I'm writing one more meter, physics over. Now m to the power of 1, another m to the power of 1. These two ones together, it becomes 2. So eventually it becomes kilogram. Look at this. M and m becomes m square s minus 2. Two ways, kilogram meter square s minus 2, or kilogram meter square per second square. Oh my God, combo of so many things. So you can short it as joule. Is that okay? Remember, force is measured in Newton, but here it is measured in joule. Easy for you. Remember, this is the unit of work in the form of a combo of base units. So it is needed for MCQ. We are done with that. I'm continuing. Power. We are looking for the unit of power. How do you get the unit of power? For that you need the equation of power, which is work divided by time. Just now we have done the unit of work is kilogram m square s minus 2 divided by time is measured in second. So how many seconds underneath? It becomes kg m square. This s minus 2. This s, when it goes to the top, it becomes s minus 1. That s minus 2 and this s minus 1 math together, it becomes minus 2 and minus 1 becomes minus 3. So that is unit of power, which is called as what? Either this way or this way, the unit of power. Now, let's go for the next one. I think one more, which is an easy one for you. No, pressure. You need to know the equation for pressure, which is force divided by area. Force, you remember, which is kilogram ms minus 2. We derived a couple of minutes before. Divided by area. Remember, area is length times width. Length we measure in meter. Width also we measure in meter. So what is the unit of area? M square. Come back. Area has a unit divided by m square. Now the math. This m square, when it goes to the top, it becomes minus 2. Already there is 1 and minus 2. So finally the unit becomes kilogram. M1, m minus 2 becomes 1 and minus 2 becomes minus 1. And what is remaining? S minus 2. So this is the unit of pressure, which is called as of Pascal. All you have to remember, you have to work out this way, and all the equations by the end of grade 12 you will be knowing. So it will be easy for you, all these multiple choice questions which is coming for the competitive exams as MCQs. Now, an easy one I am giving to you. They wanted momentum. I give you the formula for momentum, which is mass times velocity. Mass, you know, is measured in kilogram. Velocity is ms minus 1. It's an easy job. That's it on quantities. Remember, 3 types of quantities: fundamental, derived, and supplementary. Fundamental cannot be derived from any other quantity independent. Derived, a combo. There are 2 supplementary quantities. That's it. Energy also the same thing. Energy and work, they are the same. So they have the same unit. So I'm not repeating it again. Mass, kilogram. Acceleration, we did before, ms minus 2. Height, which is again meter. So 1 m, another m, it becomes m square. So kg, m square, s minus 2. That's all. Now, let's do some questions. A quantity that can be measured. Simple. We call it as a physical quantity. Acceleration is a derived physical quantity, which depends on how many fundamental quantities. How do we do this? For this, you need to know the unit of acceleration. If you remember the unit of acceleration as ms minus 2, it is a combination of meter and second. Meter, you remember distance. Second, you remember time. So it is a combo of how many quantities? 2. Force, which depends on how many fundamental quantities. You have to know the unit of force. If you remember, that is kg ms minus 2. How many quantities? Mass, distance, which is in meter, time, which is in second. So combo of 3. Charge. Is it a fundamental quantity, derived quantity, or supplementary quantity? For this, you need to remember the 7 fundamental quantities and supplementary. Remember, charge was not one among the 7 fundamental quantities. So it is not. And it doesn't belong to supplementary. Angle, solid angle. Charge is, I can write the formula for charge. It is I times T. You remember, current is a fundamental quantity. Time is also a fundamental quantity. So it is a combo of those 2. So it's a derived quantity. Now we go for assertion, reason, type. Mass, length, time are fundamental quantities. True. So assertion is true, which means this choice is wrong. They are independent on each other. That is also true. Now between these 2, why mass, length are fundamental quantities? Reason, they are independent on each other, which means reason is the correct explanation for A is the correct choice. We move on to another one. Density is a derived physical quantity. You remember, it doesn't belong to the 7 fundamental quantities. It doesn't belong to the 2 supplementary quantities. So it is a derived quantity. Assertion is true. Density cannot be derived from the fundamental physical quantities. No, density can be derived. So reason is not true. Density cannot be derived. Assertion is true. Assertion is true. Okay. Now, let's see the reason. Density cannot be derived from a fundamental quantity. Density can be derived from a fundamental quantity. So density is a derived quantity. So reason is not true. Reason is false. So the choice is C.